In this module, we will see how a pressure enthalpy chart is drawn. We will identify all different conditions of a refrigerant on this chart, and this will help us later to obtain numerical information from a pH chart for any refrigerant. So we first draw the x-axis and we have the y-axis. We will label the y-axis as pressure, and note that the scale is going to be log scale. So we have 0.1, 1, 10, and 100. And the units for pressure are bars. Note that 1 bar is equal to 1 atmosphere. We will label the x-axis as enthalpy. The units are kilojoules per kilogram of refrigerant. Now this is a regular scale, so we have 0, 100, 200, 300, and so on. Next we draw a bell-shaped curve skewed to the right. Now the left side curve we will label as saturated liquid curve. Any point on that curve represents saturated liquid state. On the left hand side, the region is for subcooled liquid, and the right hand curve we will label as saturated vapor curve. So any point on this right hand side curve represents that the refrigerant is in a saturated vapor state. Now the region on the right hand side is superheated vapors. The top point is the critical point, and we will label some numbers. So for the saturated liquid curve, we will label -50, -40, 0, 20, 30, and 90. Note that these are the temperatures, and keeping the same horizontal level on the right hand side, we will write -50, -40, 0, 20, 30, and 90. So this is corresponding to the values that we have on the left hand side. Now from the right hand curve, we will draw these lines somewhat skewed to the right hand side. So these are curves skewed to the right hand side in the superheated vapor region, and we label them as constant entropy lines, meaning that any point on any of those lines represents constant entropy value. Now from the temperature 90, we will drop a curve down. So any point on that curve represents a temperature of 90 degrees. And similarly, we will drop temperature lines from 30, 20, 0, -40, and -50. So again, these are the constant temperature curves, and they are in the superheated vapor region. On the left hand side, we don't actually see these curves on the pH chart, but we will draw these vertical lines from these various temperature values. So from 90, 30, 20, these are vertical lines, and these are the constant temperature lines in the subcooled region. Now as I said, these lines will not be shown in the pH chart for a refrigerant, but it is understood that vertical lines originating from those temperatures represent constant temperature lines in that region. Inside the bell-shaped curve, any point represents a mixture of liquid and vapors. And we draw these lines within this region inside the bell-shaped curve, and we are going to label them as quality. The numbers ranging from 10%, say 20%, 90%, and the very last line, the saturated vapor line, is 100%. And similarly, the saturated liquid line is 0%, meaning that the saturated liquid line has no vapor in it, 0% vapor. And the same thing on the saturated vapor curve, when it says 100%, that means it is 100% vapor. Quality is also sometimes called dryness fraction. You will see that name also given to quality in some of the problem. So these are all the different regions and conditions of the refrigerant that we can express on a pH diagram.